Hello guys, we want to talk about projectile and projectile motion in this video. Do well to click on the subscribe button if you're new here, and if you're old here, thanks for coming back again. Don't forget to turn on the notification bell to let you know when we drop our new video if you like what you see. So now we want to pick up a topic called projectile, and that would be useful for those that are taking further math or physics in the O level, and probably for every any other level that might make use of it. So we are going to highlight the aspects we're going to touch on the projectile, which includes what projectile actually means in terms of the definition. Then we'll talk about some things that has to do with the motion, the trajectory, the component of velocity of a body that is a projectile, and many more. So now, what is a projectile? This is an object that is launched into the air to move freely under the influence of gravity in a parabolic path. Yes. So any object that is launched into the air and it moves under the influence of gravity is a projectile. Definitely, it's going to move in a parabolic path. Example of such is a bullet fired into the air. Then you talk about a stone fired from a catapult or a javelin thrown. Those are projectile. So we can have a body launched into the air and is not moving under the influence of gravity, in the sense that it's not going to come in a parabolic path or move down again. For instance, launching a rocket into the space. So a rocket will travel with the escape velocity, and gravitational force will not be able to get hold of it before moving out of the earth crust. So this is not a projectile. So any object that is moving within the scope of gravity, and eventually gravity will take over its motion and start bringing it down when it gets to a particular height, is a projectile. So now I'm going to describe the motion of a projectile with a diagram so that we can get a clearer explanation of it. So a projectile motion is a two-dimensional motion. What do I mean by that? Let's describe the motion with this diagram. So now this represents the vertical axis and the horizontal axis. Maybe we should elongate this so we can have a clearer view. So if this position is x, so and then the other position, the other arrow represent the y in terms of the dimension. So this is the coordinate of a projectile. Now we mentioned a statement in the definition that a projectile have to travel in a parabolic path. So the shape that is called a parabola is what we are going to describe in that sense. So when we say a parabola, we're expecting something like this. Yeah. So now we're going to take this to where it's supposed to be. I'll try to adjust this so that we can have a clearer view. So then I have to reduce the size of this. So let's bring it down here. Good. So this is the motion of a projectile, and this is how it's going to look like. Yeah, exactly. So now when you launch an object, we expect it, okay, let's say you throw it from maybe a ground level, we expect it to move straight like this, so which is going to form a tangent to the motion, something like this. So you launch the object to move this way. but it eventually takes a parabolic path. So now, this is our expectation. So don't forget that the object will be launched at a particular angle. So let's say this is the angle theta. So the object is launched, which is the projectile, is launched at a particular angle. So let that angle be theta, as the case might be. So the object is launched with a velocity v, or let's say u. So if the velocity of the object is u, no, we're not going to put it there. So okay, let me make use of the pen then. So now the velocity of the object is u. Now I said this velocity have two components. So the two components of the velocity is that if you observe the motion of a projectile, let's assume this is the body performing the motion. So we expect it to move upward and forward. So starting from here, we expect it to move upward and then forward. So the object moves upward and forward as it travels along the parabolic path, upward and forward. This is okay. I mean, from this point where it was projected, it keep moving up and forward until it gets here. So at that particular position, it does not move up again, but still continue moving forward. Then after beyond that point, it begins to move downward and forward. It begins to move downward and forward beyond that point. Oh, sorry. So beyond this particular point we're talking about, the object begins to move downward and forward until it gets to the original level it was projected. So suppose we assume it is projected from the ground level, then it's going to come down again while moving downward and forward. Now, what happens is while moving upward, is working against gravity. So it's going to move upward and then forward. But when it gets to this particular point here, the point here, sorry, when it gets to that particular point, we call that point maximum height because that is the highest height reached by the projectile. Then, so this is the maximum height. When it gets to this maximum height, the force that causes its motion upward has been exhausted, so it is now under the influence of gravity here. So gravity has actually get hold of it here. Then it's going to start to bring it down and forward. So then the motion continues. We're still going to analyze a lot about this motion. Now this velocity u that we said the body is launched with is two components because we can divide this velocity u into two parts. The velocity u is divided into two parts. So we have the u with subscript x. That is the velocity it takes to move on the horizontal x-axis. Do we get that? The velocity it takes to move on the horizontal x-axis. This is the x-axis. And this is the y-axis. So the velocity it takes to move on the horizontal axis is x-axis. So and the formula given to that without wasting our time on derivation is going to be the velocity is launched with cos theta, which is the angle of projection. So theta is the angle of projection here. I'm talking about this angle here. This angle here is the angle of projection. So theta is actually the angle it is projected with. So this velocity is 1. It is launched with a particular velocity v, or sorry, u. Now this velocity has two components. Don't forget I told you that the object was moving upward and forward. So let me represent that with an arrow. It's moving upward and forward. So if the upward movement is this arrow, then the forward movement is this. So the forward movement is like this. So we assume it is moving upward, and then forward, upward and forward. That is during the motion here, during the motion between during the motion here. So during its motion in this particular place, that is from here now upward. So we believe it is moving upward and forward until it gets here where the upward motion stops. That means it gets to the highest height it could move upward, then begins to move downward and forward from that particular point, so which is called the highest height reach, maximum height. So now the velocity is 2, we have, as we have said. So the one it takes to move forward, which is the horizontal, is ux, because it is with respect to the horizontal axis. So the one it takes to move upward is with respect to the vertical axis, so that is uy. That is uy. So uy is going to be equals to u sine theta. U sine theta. So that is uy. So these are the components of the velocities of the projectile. Now, the part of a projectile is called the trajectory. So this part is parabolic, and when you talk about a parabolic equation, you talk a parabolic part, you'll be describing the part using a quadratic equation. So this particular part, I'm going to change the color so we can understand it better. So that particular part, I'm talking about this, the one that is changed to the pink color, is the parabola. That's the parabolic part. So this parabolic part is described using a quadratic equation. So how do we get the quadratic equation that is associated with this projectile motion? So we can actually look at some scenarios. Now let us consider the velocity it takes to move in the horizontal axis. Don't forget, velocity is displacement over time, so which means it takes some time for it to travel, and part of this time is used to travel along the horizontal axis. So let's label this side as point O and label this side as point A. So which means from O to A, that is the horizontal distance traveled by the projectile. So it's traveling this distance using this velocity ux, not the total velocity. The total velocity u is the velocity it takes to move both upward and forward. So we can break that velocity down into the forward velocity, which is horizontal, ux equals u cos theta, and the upward velocity, which is uy, which is u sine theta. So u here is actually the total velocity. Yes, total velocity. So but this is the velocity it takes to move upward, part of the total velocity, while this is velocity it takes to move forward, which is also part of the total velocity. So let's take this down here. So now let's proceed. in that wise, we are talking about the distance from O to A, and if we represent distance from O to A as x, so which means x is the distance along the horizontal axis, which is going to be equals to uh, velocity. You know, the velocity is displacement over time, so that displacement x will be the velocity ux times the time t in this case. So we need to note this. So which means that horizontal displacement x is gonna be equals to this ux. Don't forget, I told you, I just finished writing it here, that it is u cos theta, which is the total velocity cos the angle of projection. So we are going to write that as u cos theta times t. So that represents the horizontal distance traveled by the projectile here with respect to time. So now, what about the vertical distance traveled? The vertical distance, we are trying to derive the trajectory of a projectile now, which is this part that is in pink color. We want to derive an equation to represent that part, which we are expecting a quadratic equation. Okay. So now, the vertical axis, the distance moved on the vertical axis, y, we can also represent that using y equals ut plus, we have a general equation that we use under motion under gravity. Okay, you are familiar with this particular equation generally. S equals ut plus half at squared. So this equation is what we are going to use to derive the path along the vertical axis. Meanwhile, along the vertical axis, the acceleration that acts there is gravity, acceleration due to gravity. So we're going to change this a to g, and then we have ut here. So the u is going to be the velocity along the vertical axis, that is uy, then t, then this s is going to be the vertical distance y. So we're going to change the equation to y equals to, so this u will be uy times t, but now in this case we're going to put minus, we have to put minus reason because it is moving against gravity. So that is minus half gt squared. So that's it. So this is the equation along the vertical axis, which this represent the distance along the vertical axis y. So now we want to mix the first equation, which is x equals u cos theta t, or rather you can write it as x equals uxt. We want to mix it with this second equation y. So this is where we're going to get the trajectory of the projectile, because trajectory of the projectile is the path of the projectile, so which is respect to just x and y alone. So we have to eradicate something like t from the expression, because t has to do with time that the motion used to take place, and meanwhile the trajectory is only talking about positions in respect to x and y only. So we have to just consider changing the expression. So uy, we are going to write it as y equals u cos theta, sorry, u sin theta, since it is uy, u sin theta, then multiply by t minus half gt squared. So we're about to get the formula for the trajectory. Now, the purpose of doing this is we are going to convert this y to a function of x, because presently this equation here shows that y is a function of t. So it shows this is y as a function of t. So we don't want y as a function of t again. We want y as a function of x so that we can get what is called the trajectory of the projectile, which is the path. So now let's go back to this. I'm going to make t the subject of the formula here. I'm going to make t the subject of formula. So I'm going to be having t equals x over u cos theta. So if that is the case, I can actually take that expression to everywhere we have t. That is t equals x over u cos theta. So wherever I see t, I can put y equals u sine theta into brackets. So t becomes x over u cos theta. So then minus half g. So then t also is x over u cos theta. So closing the bracket and square it, so that is t. So what next are we going to do here? Let us try to do the simple maths left. So here now I'll be having y equals u, we definitely cancel u. Then if you have sine theta times x, you'll be having sine theta times x over cos theta minus, so this will be 1 over 2 times gravity times x squared over u squared cos squared theta. So in this case, what next is we have sine theta over cos theta here, which is tan theta. So y equals tan theta minus, then I can write this as x squared, or probably I could write this as 1 over 2g. Okay, let's put it in a very more simpler way. So I can have g times 1 is g over 2u squared 2u squared cos squared theta multiplied by x squared. So you take note of this. You already have, okay, sorry, we omitted something here. Sine theta over cos theta is tan theta. Then we have x up there. So there is x here. So I have to put the x back. So I can put it as x. And that will give x tan theta. So if we look at this form, we already express y in terms of x. So this is y equals x tan theta minus g over 2u squared cos squared theta x squared. So this is already a typical form of quadratic equation to prove that the path of a projectile is parabolic. So we've gotten this expression as a quadratic equation. Just you know that if we write it as a quadratic equation, it's going to be y equals you can have bx plus ax squared. So in this case now, b is tan theta, while a is minus g over 2u squared cos squared theta. So this already proved that the part of a projectile is parabolic. So this equation here is actually the part, or you call the trajectory of a projectile. This is the equation to represent the trajectory of a projectile. So we are going to discuss the other parts of projectile, that is talking about time of flight and many other things we need to know, in the second video for projectile. So thanks for watching. Please subscribe to the channel, it's free. So the next video we're going to talk about the other parts that we need to consider in projectile, and then we go into question solving on it for the case of those that will be needing it for one or two exams. Thanks for watching.